So for my chemistry students, I wanted to go over acid-base titrations because this is a nice combination of talking about acids and bases, what concepts at play there, and how this gets together with stoichiometry. And my daughter and I will do some demonstrations here for you in the next couple videos. So what we're going to do is we're going to mix sodium hydroxide with vinegar. And the first video, we're going to do it for you. We're not going to make you figure anything out. But the other ones, then you're going to have to figure out. So, for example, sodium hydroxide, so the sodium plus oxygen plus hydrogen, has a molecular weight of 40 grams per mole. So we're going to put in the cup 1 gram of sodium hydroxide. So you convert that, that's 0.025 moles of sodium hydroxide. When you mix that with vinegar, so the hydroxide is your base, OH minus, the vinegar is supplying the acid, and we've seen that before. That's giving us our H plus. So when you do a titration, you're trying to make things come out perfectly so that all of your acid and all of your base completely nuke each other or neutralize each other. So you're going to need exact amount of moles of acid to nuke the amount of base. And what are you going to get? Well, you're going to get water because H plus OH minus, that gives you water. And then you're going to get sodium acetate as your salt. When you do an acid-base titration, you usually get water plus a salt. You guys are used to seeing things like sodium chloride or potassium chloride. This is sodium acetate. It's a much bigger salt, but it's still a salt. It's used in a lot of preservatives, actually. So how much acid are you going to need, and how are you going to figure it out? Well, a lot of times you've got a molarity of an acid, and you already know how many moles you need, so you just got to figure out the volume. So here you go. Where's my clip? There we go. So vinegar, and it's a 5% solution of vinegar, but if you look up online, vinegar actually has a molarity of 0.833 molar. So that tells us how concentrated our vinegar is. And we know how many moles of acid we're going to need, so you can actually work out how you're going to nuke it. We know how much acid we need. We know the strength. Well, using molarity, we can figure out the volume. Oh, well, 0.25 divided by something is give us 0.833. We'll flip them around, and when you do that, you should get something that's really close to 0.03 liters or 30 milliliters. So when we do these, we're going to set it up for you. And the first one we're going to do, so all of our base and all of our acid, known amounts, are going to come together, and they're going to completely neutralize each other. When you do strong acid and strong base, when you neutralize, you wind up neutralizing at a pH of 7. Sodium hydroxide is a strong base. Vinegar is not a strong acid. So when you see our indicator, it's not going to be at a pH of 7. It's going to be different. But that doesn't mean we haven't neutralized the acid or the base. The pH is just going to be a little bit off. And that's okay. Works totally fine. So the first one, we're going to do exactly like this. The other ones, we're going to set up the scenario saying, hey, we've got, so many grams of sodium hydroxide in here. Set up the problem. How much vinegar do you think we're going to need to neutralize it? Make you figure it out, and then we'll do it in front of you. And the other one, we're going to do reverse, saying, hey, we've got so many milliliters of vinegar. How much sodium hydroxide are we going to need to add to this to titrate to it to get it to completely neutralize? That's the game. We're going to model one for you. You're going to have to calculate the other two.